Kia ora. In this video I'm just going to talk about the basics of the two Arduino chips and then discuss a little bit on the inputs and outputs. Now the chips that we'll be using for experiments is this one, which I've got a connection plug like this to the USB, and the chips that you'll be later using in your projects has got a mini USB. That means the same cable that you can charge any Android phone with will help, work to download programming onto it. So this is the one that you'll use, and this is the one that we'll currently use in our projects. So they're basically both the same Arduino Uno chips. There's no difference between them. The only difference is these chips. This is an external power source, so you can power it. You can either power it through here or through there, and the idea is probably if you've got a power bank to charge your phone, you can power your chip through that as well, so it doesn't need to be connected to the computer the whole time. So just talking about the legs and how it works, on the Arduino chip there are inputs and outputs. So if we just take this one for instance, or the one that you're going to use, so we've got here from 0 to 13. It can be either inputs and outputs. In our case, we'll just use it for outputs at this stage. And then you've got a ground, which is negative, so 1 to 13, and then a ground that's negative. And on this side, we'll have a 5 volt output as well, a 3.3 volt and a 5 volt, and then 2 extra negatives. So this is the chip without the shield, the breadboard shield on. I'll just quickly show you guys how we're going to construct the blink circuit. So if you, for instance, plug in this into your device, that shows you that the chip has got power, and that's the same as leg 13. So if we've got the blink circuit on, you can see it blinks on leg 13 there, but you can put an external LED in as well. Remember, long leg positive, short leg negative. So the long leg will go into 13, and you'll put the short leg into ground, and then your LED will flash there. The same for this one. So if I want to do a flasher circuit, on this one we'll probably do the fade. Now fade is this LED that's flashing like that's got a square wave type, so it switches on and directly off. But your flashing circuit, I've got a what we call a sawtooth circuit, or wave, which will switch on and gradually switch off, so it fades out. And that one goes from 9 to ground, so you'll just go into 9 with your positive there, and then your other leg will go to ground. You can also use an external breadboard on these with jumper wires, so you'll put an external breadboard on and you can grab some jumper wires, and we'll just so we've got these jumper wires with already 2 points on it. So if I want to do this on the external breadboard, I can put my LED with the negative to negative and the positive to positive. So I'll just take 13 to positive on the breadboard, and I'll take 9 ground, which is next door to it, to the negative. So this is the same idea, but we're just doing it on a breadboard. A breadboard gives you more options for more complex circuits, whereas if you plug it in here, you'll only have this few. So that's basically the blink circuit. The blink circuit is available under examples, and I'll show that in the other video how we can access the bleed circuit and manipulate the blink circuit and the fade circuit. So just you'll see you can change the speed that it link by changing your delay time, and it comes up with normally with 100 milliseconds delay time, and then you can change it to 1000, or you can make it less as well and see the difference in your flashing LED. You can also have multiple LEDs flashing, and if you want to, you can build your traffic light circuit that you've already done on Tinkercad onto this breadboard, or and yeah, that's basically it. Arduino Uno 0 to 13, they're all the same, and then there's your ground is your negative, and then you've got a 3 volts, 3.3 volt, 5 volt, and then 2 extra grounds. That's basically the parts that we'll use. This part of the board is basically the translator part that translated from the code into zeros and ones, or to binary code, and that's your chip with a counter there, and your power LED and your onboard LEDs over there, leg 13, or which will work the same as leg 13.